Let's have a look at some examples now involving parallel line geometry. So we're going to find the value of each pronumeral and just give a brief reason. So let's have a look at part A. Part A, we've got a parallel line there, or a pair of parallel lines. We have a transversal, and we've got two angles. Okay, so we have an angle X and 63 degrees. Okay, when we have an angle pair with parallel lines, generally speaking, it's either going to be alternate, corresponding, or co-interior. So what do you think this angle pair is going to be? Okay, think of it this way. One angle is to the left of the transversal, the other angle is to the right. One angle is below a parallel line, the other angle is above a parallel line. Okay, what do you call something that tends to go from sort of to and fro, right, from one side to the other? Word beginning with A. Alternate or alternate. So this is an example of alternate angles. Okay, so x degrees is equal to 63 degrees, or x is equal to 63 degrees, and the reason is they are alternate angles. Okay, let's have a look at part B. What do you call angles that are on the same side of the transversal and also on the same side of their respective parallel line? The A degrees is above, so is the 71. A is to the left, so is the 71 degrees. So what do you call what do you call two things that are basically in the same relative position? Okay, call them corresponding. So A is equal to 71 degrees, and the reason is corresponding angles, okay, are equal. But suffice to say that you've identified that they're corresponding angles and they would be equal. Last one. Okay, we've got two pronumerals there. We have 80 degrees, we've got a y degrees, and we have a w there. Okay, so I might just move this over a little bit. Zoom that in a little bit there. Okay. What do you think we should do first? Okay, we can probably identify that the y and the 80 degrees are co-interior. Okay, so what do you know about co-interior angles? Okay, so it sort of forms like a C shape. Co-interior angles are supplementary, right? They add up to 180 degrees. Okay, so y plus 80, right, is equal to 180 degrees. Okay, y is equal to 180 minus 80, okay, which equals 100 degrees. Okay, and the reason for that is co-interior angles. Okay, so y is equal to 100 degrees. Okay, so what would be angle W then? Okay, so I'm just going to move the board there. What would be angle W? Look at the relationship between W and Y. What do you call two angles that are opposite each other where there's two lines that cross over each other? Okay, or they intersect. They're called vertically opposite. Vertically opposite angles are equal. Okay, so I'm just going to right there. Okay, so W is equal to Y, which is equal to 100 degrees, and the reason is vertically opposite angles. Sorry, it's a bit squashy there, but vertically opposite angles. So this is also 100 degrees because they are vertically opposite to each other. All right, one more question, and this one is a proof. Okay, notice this time I've drawn what appears to be parallel lines, but I can't put the arrows in. In fact, I had to remove those arrows because we're trying to prove something here. We're trying to prove that AB is parallel to CD. In other words, we'd like to put the arrows in. Okay, these arrows. How do we know that they're parallel? Okay, it's a bit like proving that a triangle is in fact right-angled by using Pythagoras' theorem and proving that a squared plus b squared equals c squared. Kind of a similar sort of thought process there. What do? Okay, we either need to show a pair of alternate angles, corresponding angles, or co-interior angles. Okay, so you can choose whatever, however way you want to do this. As long as you can show one of those three angles or angle pairs are present, then that proves that AB and CD are in fact parallel to each other. So I think what we'll do is I might find this angle here. Okay, we'll call that X, and maybe show, if possible, that these two angles are in fact co-interior. So let's write the proof. So first of all, angle, okay, CFE. This is how we write the proof. Okay, angle CFE is equal to angle. Okay, I just need to put an extra letter here. Is equal to, actually, no, I won't do that. It's equal to 103 degrees. Yep. Okay, I probably should have put in, probably should have placed labels on these, on the transversal, the end of the transversal, but not going to be needed here. So angle CFE, okay, so this angle here is equal to 103 degrees. And the reason for that is vertically opposite. Okay, so I'll just put that there. All right. Now what do you notice? We've got 77 degrees and 103 degrees there. They look like they're co-interior. Okay, so angle AEF, okay, plus angle CFE. Okay, notice that the middle letter corresponds to the vertex, okay, of whichever angle that I'm looking at. Okay, angle AEF, what's that? 77 degrees. Angle CFE is 103. Okay, 77 plus 103 is equal to 180 degrees. That means that AEF, okay, and CFE are supplementary and are co-interior. Okay. Angle CFE are co-interior. Therefore, AB is parallel to CD. This symbol here, that means parallel to. Okay, so AB is parallel to CD. Okay, and that's just a very basic proof, but can we now place the arrows on the parallel lines AB and CD? Now we can.